Welcome to the Math Record. Today I'll be covering the ICTM Regional 2016 Division A Algebra 2. Okay, let's get started. Number 1, let f of x is equal to x cubed, or a cubic function. Determine the value of the inverse of 8. So if it's inverse, that means whatever they put inside is going to be the y-coordinate. So 8 is going to be equal to x cubed, so x is equal to 2. And that's basically it. So the first answer is 2. Okay. Let K represent an irrational number and let W represent an irrational number. Is it possible for the product of KW to represent a rational number? Um, if you don't know, it's going to be yes. So the reason is, let's say an irrational number would be like, let's say square root 3, right? That's irrational. So let's say both of K and W square root 3. If you multiply them together, that's 3. That's rational. And that's the reason why. So that's one of the reasons why that could like kind of work. So 2 is definitely a yes. So 3, determine the value of n such that n factorial is equal to 24. So 1 factorial is equal to 1, 2 factorial is equal to 2, 3 factorial is equal to 3 times 2 is 6, and 4 factorial is just 4 times 6 is 24, right? So n is going to be equal to 4. So that's kind of just if you want to memorize it. I usually memorize from 1, 2, 3, 4, 5 factorial. So it's 1, 2, 6, 24, 120. And if you want to put 6, that's 720. So if you want to like memorize it, you could. But it's one of the more simpler questions. So 1, 2, and 3 are definitely simple. So number 4, the roots for x of x to the power 4 minus 7x to 3 plus x a times x squared plus cx plus 24 equals 0, or p plus 1 and um, plus plus or minus bi, where so they're imaginary and b is greater than 0. Okay, determine the exact length of p plus b. So the idea of having a polynomial, let's just use this case as a quadric. So it's x4, and let's kind of just use some random coefficients. So we have a x cubed plus b x squared. Actually, make this a plus ax squared plus bx plus c. So this a is not equal to a equation. I'm just using its example. A is going to be equal to the sum, or equal to the -1 times the sum of the roots. So sum of the roots. B is equal to the sum equals to the sum of the roots multiplied together. Multiplied in pairs, basically, in pairs. And C is equal to just the product of all the roots. So it's kind of weird. So how it's gonna work is this usually follows for every single polynomial. So that means -7 is equal to the sum of all the roots times -1. So our sum is equal to 7. So 7 is equal to p plus the p plus 1 plus the bi plus the -bi, right? So, and 24, which is our product, is going to be equal to p times p plus 1 times our bi times our -bi. So that's just a property that you just need to know. So 7 is equal to 2p plus 1, right? Because the bi plus a -bi cancel each other out. So that means our p is equal to 3, right? So 7 equals to 2p plus 1, right? So p is equal to 3. So we know that's true. So if p is equal to 3, let's just substitute into this equation, which is 24 is equal to 3 times 3 plus 1 is 4, times bi times -bi. So I times I is I squared root's -1. So I squared is equal to -1. So -1 times this -1 is positive. So that just leaves b times b, which is b squared. Okay. So 24 divided by 12 is 2. So that's equal to 2 is equal to b squared. So b is equal to square root 2. And b has to be positive, so it's not negative square root 2. It's just square root 2. So to find the exact value of p plus b, P we set right here was equal to 3, and B is equal to square root 2, so the exact answer is 3 plus square root 2. And that's it. You just need to know your properties of polynomials. Number 5. Absolute value of x minus 3 over 1 minus x is less than 1 minus x minus 1. Determine the least possible value for x such that the inequality is true. So if absolute value, let's kind of work that out. Actually, I'm just going to rewrite this as say this negative x plus 1. I usually like to have the variable in front, minus 1. Okay, so if the inside of x minus 3 over negative x plus 1 is positive, we could just say x minus 3 over negative x plus 1 is less than x minus 1. So this is going to be true. I'm going to move this over so I have room. Okay. And also, if x minus 3 over negative x plus 1 is negative, we just need to multiply this by negative. So that will make us x minus negative x plus 3 over negative x plus 1 is less than or equal to x minus 1. So using that idea, we could just move this equation to the other side. So that would be x minus 3 negative x plus 1 minus the x minus 1, which is the same thing as saying x minus 1 times negative x plus 1 all over negative x plus 1, right? So that gives us that is equal to I mean, it's less than equal to 0 because we moved it to the other side. So this simplifies to x minus 3. So this is negative x squared, so with that negative is positive x squared. And then that's x plus x, so then plus 2x, and then minus 2x because there's this negative. Negative 1 times 1 is negative 1 times this negative is plus 1. All over negative x plus 1, right? So this is our first part. And you can simplify this even further to say it's equal to x squared, right, minus x, negative 2x and x. And this one is minus 2 over negative x plus 1. Okay, so we find out what this all simplifies down to. So let's kind of delete all this because I need the space. And let's kind of do the other equation now. So we're going to do the same thing. So negative x plus 3 over x plus 1 minus x minus 1 times x plus 1. What is negative x? Negative x over negative x plus 1, right? So this will be equal to negative x plus 3 minus, so x times negative x, so negative x squared, plus times negative plus x squared, plus x, that's plus 2x, and minus, so minus 2x. And then negative 1 times 1, negative 1 times negative plus 1, all over negative x plus 1. So this simplifies to x squared minus 3x plus a 4. Okay, over negative x plus 1. So let's delete this because we don't need that anymore because we're just trying to simplify it. So it's equal to this equation. So this could be the same. So going back to this one, this could be x minus 2 times x plus 1 all over negative x plus 1. So, so if you kind of think about it, our restriction has been negative infinity to negative 1. And then from negative 1, and then you have 1 here, and then 1 to 2, and then 2 to infinity. So you need this to be less than or equal to 0, less than or equal to 0, right? So you want this to be negative. So if we put in like, let's say -2 in here, that's gonna be a negative times a negative um, over a positive. So negative times a negative is gonna be equal to a positive, and positive over a positive is positive. So this one doesn't work. So -1 and 1. Let's just put in 0. So that's -2 times a positive times a negative times a positive is a negative over a positive is a negative. So this definitely works. Now, between a 1 and 2, let's use 1.5. So 1.5 minus 2, that's a negative. 1.5 plus 1 is a positive. So we have a negative on top, and then we have a negative on the bottom. So negative times negative, negative divided by negative is positive. So this doesn't work. Now we have something like a really big positive. Okay, so let's say like 3. So 3 minus 2 is 1. 3 plus 1 is 4. So they're both positive. And then negative 3 plus 1 is -2. So that's negative. So positive divided by negative is negative. So this one definitely works. So the solution set for just this equation is -1, 1, and 2 to infinity. Okay, so we know the solution set for that. Complete. Okay, somewhat clean enough. So we know that's true. Now let's do the solution set for this one. So we have x minus, let's say 3 over 2 squared. So that's x minus 6. Yeah, so this is plus 9 over 4, which is just equal to 2.25. So that means we need to add 1.75. So this tells us that there's no roots because the equation is gonna look something like up here as a parabola. Just this top part, not including the bottom. So it doesn't. So it's never gonna have a so it's always gonna be positive on the top. So the only way for this to be negative is that if the bottom is gonna become negative, and that's only if when x has to be less than, I mean actually has to be greater than 0, greater than 1. Okay, so it has to be greater than 1. Then the least possible answer based on this solution set is that it can't be any of these because it has to be greater than 1. So the smallest possible is that 2. So the answer for number 5 is 2. Oh, sorry about that. 2. Okay. Okay, number 6. Sam rolls 2 fair standard cubical dice. Determine the probability that the sum of the number of the upper faces would be equal or greater than 5. So let's kind of make a chart. So 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. So let's say our first dice, the probabilities is the possibilities are 1, 2, 3, 4, 5, and 6, right? And the second dice is 1, 2, 3, 4, 5, 6. So 1 and 1 together is 2. This is gonna be 3. 3 plus 1 is 4. That's a 5. That's a 6. That's a 7. So this chart is gonna be our entire possibility. So this is a 3. That's a 4. That's a 5. That's a 6. That's a 7. 2 plus 2 is 4. So that's a 5. That's a 6. That's a 7. And that's an 8. 2 plus 3, that's a 5. So you kind of see the pattern. So 6, 7, 8, 9. 6, 7, 8, 9, 10. 7, 8, 9, 10, 11. And 8, 9, 10, 11, 12. Okay, so these are all the possibilities. So it's greater than or equal to 5, right? So it's all these, right? All these numbers down here. Okay, so we have how many, what's the total possibility? There's 6 here and there's 6 here. So 6 times 6 is 36. So there's 36 possibilities on the bottom. So we know there's 36 on top minus the ones that are not there. So there's only 2, 3s, and 4s that are not. So there's 1, 2, 3, 4, 5, 6. So we minus 6 away because those are the ones that are not 5 or is not 5 or greater than 5. So that's 30 over 36, and that simplifies to 5 over 6. So our answer for number 6 is 5 over 6. Okay. Number 7, let W be a symbol for the digit 12 in the base system, and let K represent an integer. Okay, so if X represent a base 10 number such that X is equal to 16K, 16 base K, and X cubed is equal to 281 W base K, determine the value of K. Okay, so let's convert them all to base 10. So that's equal to just 6. And then next term is 1. So 1 times k is equal to, that's equal to 6 plus k. Okay, so and then x cubed, convert to base 10. That's equal to w, which is 12, plus 1 times k, plus 8 times k squared, plus 2 times k 3. So if you don't know how to do base conversions, that's basically how you do it. The smallest, the units digit, is gonna be raised to the 0 power, so you just multiply by nothing. And then the first one is like the 1. It's gonna be, in this case, is raised to a first power. Then the next one is raised to the second. Then the next one is raised to a third, and then after that is the fourth, then to the fifth, then to the sixth, etc. Right? So that's basically how you do base conversions. So that basically tells us, oops, x cubed is equal to 12 plus k plus 8k squared plus 2k cubed. And we know what x is. X is just 6 plus k. So then k plus 6, I'm just going to rewrite it because I like the variable in front, cubed is equal to 2x cubed plus 8k squared plus k plus 12, right? I usually like to have the highest terms on the top, and that's the reason why. Okay. Now we just need to simplify this and find what k is. So this side is gonna expand out, let's say k squared plus 12k plus 6 times a k plus 6, right? I'm just trying to get the side. So that's equal to k cubed plus a 18k plus a 72, what is it, 72? Wait, 72, 78, 78k plus a 36. So is that right? Uh, oops. Sorry, that's kind of off. That's 108. Sorry about that. K. This is k squared. So, and then plus 216. So, k cubed plus 6k plus 12k. Oops, this was a 36. Sorry about that. And 36 and 72, 108. Yeah, so this is equal to 2k cubed plus 8k squared plus k plus 12. And simplifying, 2k cubed minus k cubed is equal to k cubed. And then minus k squared. And then minus 107k. And then minus 214 is equal to 0. So using your calculator, you kind of could just graph it out and see how that looks. Graph it out and find where the 0 is. Or if you have an Nspire, you could be able to find it pretty easily. If you know how to use your TI-84. I recommend just using a TI-84 or Nspire, which is like the best to find like basically anything. So we have so the answer, if you're graphing, then you just like find the 0. So the answer for this question is negative 214. It's gonna be 17. Oh, wait, just 204. Sorry about that. Yeah, is equal to 17. Because that's the only positive. There's zeros at -4, -3, and 17, but it has to be a positive base, so it has to be 17. Okay, that's number 7. And number 8. Let log base b of 5 is equal to x, log base b of 3 is equal to y. So then we have to find this, okay? Where we are at k plus w plus p. So log, oops, log. So it's 135. You're taking the cube root of 135 times b. So if anything is cube rooted or raised to a power, you can just move that to the outside. So it's 1/3. This is cubed, so it's 1/3. A base b of 135 times b, 135b, which is the same thing as saying 1/3 parentheses log b 135 plus. So these are just some log rules and properties you need to know. So log b of b. So that tells us 1/3 of log b 135. Log b of b is just 1. And then what's 135? That's log b. You could divide a 5 out. So log base b. So that will be equal to 27, right? So log b of 27 plus 1. So 1/3 of log b 5 plus. This is just 3 raised to the power of 3, so it's 3 times log b of 3 plus 1. So we can just substitute everything in. So log b of 5 is x plus 3 times log b of 3, which is y, plus a 1, right? So that's 1/3 x. Oops. So 1/3 times x is 1/3 x plus a y plus a 1/3, right? So the 1/3 plus 1 plus 1/3, because those are the coefficients, is equal to, that's 2 over 3, that's 3 over 3, so that's 5 over 3. So our answer for number 8 is 5 over 3. Okay, question 9. 3 monkeys randomly toss a total of 24 indistinguishable ping pong balls into 3 containers ABC. Each ball is equally likely to end up in one of these containers, and all balls go into one of these containers. Determine the number of distinct outcomes that are possible. The order in which the balls in the container doesn't matter, just the outcome, right? So it doesn't matter like if you put, okay, so what they're trying to say is, let's say we have 3 containers, right? And you throw the first one in here, the second one in here, and the third one in here. So each of them had 3 balls, okay? Now think about the scenario where we have 3 more containers, right? And we throw the first one in the middle, and then the second in here, and then the third one in here. They still have 3 balls in the end, so it doesn't matter which order they throw it on. If they all have the same possibility in the end, then it's gonna be just one combination. So since that doesn't matter, that means it doesn't matter that there's 3 monkeys. So because the only thing that matters is how many balls are in each container. So let's kind of think about this. So we have a we have 3 containers and there's 24 ping pong balls, right? So let's keep the first one 0. Let's say there's no balls in the first container, in container A, and this is B, and this is C. Okay. So if there's 0 in the B, that means there's 24 in here. Now if there's 1 in here, that means there's 23 in here. Now if there's 2 in here, that means there's 22 in here, right? Because there's need to be a total of 24. So this could go all the way to 24, and this could go all the way to 0, right? So it has to exchange like this, right? Because if this goes up 1, this has to go down 1. So it went from 0 to 24, so that means there's a total of 25 combinations. So when A has 0 balls, you have 25 combinations. Okay, so let's test when it has only one combination. I mean, when it only has 1 ball in here. If A has 1 ball, then if there's 0 balls in here, that means there's 23 in here. That means if there's 1 here, there's 22 here, there's 2 here, there's 21 in here. If there's 3 here, there is 20 in here, right? So this could go all the way to 23, and this will go all the way to 0, right? Because 1 plus 23 is 24, and then plus 0 is 24, right? So how many combinations can you go? You went from 0 to 23, so there's a total of 24 combinations when you keep A as 1. Okay, so we're seeing a pattern here, kind of. So now if you keep 2 balls in A, then if you have 0 here, that means there's 22 here. If there's 1 here, there's 21 here. If there's 2 here, there's 20 here. And if there's 3 here, there's 19 here, right? So it's basically just the same thing over and over. But we're trying to find out how many combinations are in each of B and C, how many combinations there are when A only has a 0 ball, 1 ball, 2 balls, 3 balls, 4 balls, 5, 6, 7, 8, 9, right? All the way up to 24. So we see that it's 0, 1, 2, 3, and then 20, 21, 29. So you increase 1, you decrease 1 here. Okay, so this all could go all the way to 22, and this go all the way to 0, because 2 plus 22 is 24, right? Keep it at 24. So this is the maximum at the end. So you went from 0 to 22, which is 23. Okay, so we kind of see a pattern. You subtract 1 to get to 24, you subtract 1 to get to 23. Okay, so let's kind of see if that's true. Let's Because if the next one is equal to 3, then you could kind of generalize it and say that it's just going down from 25 to 0, right? So if A has 3 balls, then there's 0 here, there's 21 here. There's 1 here, there's 20. There's 2 here, there's 19. There's 3 here. This is going to be 18, I believe. And this go all the way to 21. And this goes all the way to 0, right? Because 3 plus 21 is 24. So it went from 0 to 20, 22, 21. So that is a 22 combinations. Oh, so we kind of see a pattern going on. So instead of doing all this and wasting time, all we could do is just find the sum. So we need to find 25 plus 24 plus 23 plus 22 plus 21 plus 20 plus 19 plus 18, etc., right? So you have to add all the numbers from 25 down to 0, which is basically an arithmetic sum from 0 to 25, right? So you have to add all the numbers between there. So the arithmetic sum is the number of terms, which is 0 to 25, which is 26, divided by 2, and the first term is 0, and the last term is 25, right? So 26 divided by 2 is 13, and 13 times 0 plus 25, which is 25. So that is 13 times 25 is 325. So your answer for number 9 is 325 combinations. Okay. Number 10. Let k be the numerical value of the area enclosed by 2x minus 1 plus y plus 3 is equal to 8. Okay, so when they have two absolute values like that, and they have and there's an x in one of them and y in the other, what it's gonna look like is gonna look like a diamond. So, like you could graph this out and see how this looks, but it's gonna be a diamond. So, the ending points here, you could kind of just focus on one equation at a time. So we have 2x minus 1 absolute value has equal to 8. So that means 2x minus 1 has to be equal to 8, or 2x minus 1 is equal to negative 8. So x right here is positive, right? So x plus 1 is 9. 9 divided by 2 is 4.5. So this is 4.5. Okay, negative 8 plus 1 is negative 7. Negative 7 divided by 2 is negative 3.5. So right here is negative 3.5. Okay, so we got that part done. So that's the x. Now let's do the y. Oops. Make this longer. So the y is absolute value of y plus 3 is equal to 8. So that means y plus 3 has to be equal to 8, or y plus 3 is equal to negative 8. Right? So y is equal to 5, or y is going to be equal to negative 11. Right? So that means the area between them, the area of a diamond is just the height times the base times the height divided by 2, right? Because you kind of make a rectangle, right? It's just base times height divided by 2, because this area is equal to this is equal to this is equal to this, and this is equal to this, right? That's why it's half. So all we need to do is just 5 to 11 is 16. Negative 3.5 to 4.5 is 8. So 16 times 8 times a half. That is equal to 64. So the answer for number 10, so the area in that graph is equal to 64. Okay, number 11. P of x is equal to x squared and q of x is equal to x plus 3, where p of f of x is equal to q inside p and g of x is equal to p inside q. Determine the value such that f of x is equal to 2gx. So f of x is q inside p, so it's going to be 2x plus 4 inside the x squared, which is this squared. Let's kind of move this over so we kind of have room to see this. Okay. So that's f of x, and that is equal to 2 times g of x. G of x is p inside q of x. So that is 2 times 2, and then you put the x squared inside that x. So that's just 2x squared plus a 4. So that's g of x. So that means this is 4x squared, that's 8, that's 16x, that's plus 16, equal to 4x squared plus 8. So both x squares on here can cancel out. So 16x is equal to 8 minus 16, which is negative 8. So x is equal to negative 1 half. So the value for our 11 is just negative 1 half. And that's basically it. Okay. Number 12. X is equal to the square root of 33 plus square root of 33 inside plus square root of 33 inside plus etc. 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 So it goes on for infinity. So let's say x, right? X is equal to square root 33, right? So the trick to do this is square root 33 is that you're gonna find out where it is. So in this equation, we know that x is equal to square root 33, right? Plus square root 33. Now you can put this x because this is the same thing as this, right? That means you could also put inside here. Okay, so it's kind of so imagine we substitute this x with the square root 33 plus square root 33 plus square root 33, right? Inside, 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 right? It's basically the same thing. So we could rewrite it as this. So then we could square both sides is equal to 33 plus x. So x squared minus x minus 33 is equal to 0. And then we could just use the quadratic formula. So negative b plus or minus b squared, which is 1, minus 4 times an a, which is 1, times a c, which is negative 3, negative 33, over 2a. So that simplifies to 1. So this got to be 33 times 4 plus 1 is equal to 133. So you can't minus it because then it's going to get negative, so you have to plus it. So plus 133 over 2. So our k is 1, our p is 1, our w is 133, and our q is 2. So to add them all together, that's 1 plus 1 plus 133 plus 2. You get an answer of 137. And that's for 12. It's basically just that simple. You just need to find out where that pattern repeats. Okay, in the given diagram, P lies on the parabola. So P is just a point on the parabola. V is the vertex, F is the focus, and QD is the, wait, where QD, line QD is the directrix, and the lattice rectum of is LR. Okay, so you can just look at the diagram, right? So determine which of the following statements are false. Okay, so this is just gonna test your properties based on your if you know connexes. So connexes are parabolas, circles, ellipses, or hyperbolas, right? So look something like this. I'm not the best artist, so let's kind of still make it kind of nice-ish. So something like this, and just say this is V, this is Q, this is line QD, right? Line QD. That's our directrix. Our focus is right here, and our lattice rectum, which is L right here and R right here. Okay, so they said, so which one is false? A, they say f of v is equal to v of q. So this is equal to this. Well, this is true. The focus to the vertex is equal to the distance between your vertex to your directrix. So that's true. So A is true. That's just a property. So this is just gonna test you in like the reason you're probably gonna get this wrong if you don't is because you don't know the properties, and that's basically it. So it's kind of a weird math question. And they say via p, so v, okay, I forgot p. P is like right here. So it's a point on the graph. V of p is equal to p to d. Okay, so that is not true. So the vertex to a point in the graph is not equal to that point all the way to the directrix. That is just simply not true. That's not a property. What is true is that the focus to the point is equal to the point to the directrix. So that is true, but not V to P. It's F to P. So B is wrong. So that's a possible answer. So now C, F to P is equal to P to D. Okay, so that's what I just talked about. The focus to a point on the graph, that distance is equal to that point of the graph to the directrix. So that's just true. And they say L to F is equal to Q to F, right? Which is true. The lattice rectum, right? The lattice rectum, if you put the distance from LF and you put the distance from the directrix to the focus, right? Then the lattice rectum is 2 times that distance. So you put in half of it, right, from just L to F instead of L to R, then it's gonna be the entire length of from the focus to the directrix. So D is true. So the only one that's false out of 13 is B, and that's your answer. It's a weird question. You just basically need to know its properties. Number 4, determine the value of k such that 2 over 6x plus 1 plus 3 over 6x is equal to 5 times 2k is equal to 6x plus 1 for all value x, such that like if you put anything for x is always going to be true. Okay, so we have 2 over 6x to power to 6x plus 1 plus 3. So we want to make this 6x plus 1 on the bottom, right? So since there's already 6x, we just need to multiply the bottom by 1, right? So it's like this. So multiply by 1. Oh, multiply by 6 over 6. So this 6 times this 6x would just make this a plus 1, right? So then it's just 3 times the 6, which is 18. So this is the same thing as saying 18 over 6x plus 1 is equal to a 5 times 2 power of k over 6x plus 1. So adding them together, that's 20 over 6x plus 1 is equal to 5 times 2 to the power of k, 6x plus 1. So 20 is equal to 5 times 2k. So 4 is equal to 2k. And 4 is just equal to 2 to the power 2. So k is equal to 2. So the answer for 14 is just 2. And that's it. Okay. Basically, just need to know how to do your exponents, like multiplying exponents. Determine all view values of x such that the absolute value of 2x minus 5 is equal to absolute value of 4 plus 3x plus 1. So let's kind of write that out. So 2x minus 5. I like to put the variable in front, so we're going to write 3x plus 4 and plus 1. So let's work on each side. So let's say 2x minus 5 is positive. So 2x minus 5 is positive. That's equal to 3x plus 4 absolute value plus 1. Right? So just move the plus 1 to the other side. So we could say that is just minus 1 from 5, so that's a minus 6. So that 5 becomes a 6. Okay. And if negative 2x, if 2x minus 5 is negative, you could just say that, multiply that by negative to make it positive. So that's equal to negative. So that's the next possibility. So negative 2x plus 5 is equal to 3x plus 4. So you have to minus that 1 to the other side. So that's 2x plus 4 equal to absolute value of 3x plus 4. So now we have to do it again. So we're going to have 4 possible combinations, right? 2 from here and 2 from here. So this means there's 2x minus 6 is equal to 3x plus 4 if it's positive, and 2x minus 6 is equal to negative 3x minus 4, and from here is 2x plus 4 is equal to 3x plus 4, or it's negative 2x plus 4 is equal to negative 3, negative 3x minus 4. Right, so let's do the first one. So that simplifies to x is equal to negative 10, right? So this one is negative 10, right, as our answer. And I'll just write on the bottom so we don't get confused. And the second one, we add the 3 here, so that's 5x. And add the 6 here, so that's 2. So x is 2 over 5. 2 over 5. So we have negative 10 and 2 over 5. Those are our first two possibilities. Now let's do this one. So that's 5x is equal to 0, right? So x is equal to 0. So the first possibility for this one is 0. And the second possibility, you add the 3x to this side, so x is equal to negative 4 minus this 4, that's negative 8, right? So the next possibility is negative 8. So we have 4 possible answers. Now let's check which ones are actually the answers. So we can just plug it into the equation. So plug everything back into here, right? Into that one, right? So all 4 of them, plug it in so you can test which one is the actual answer, right? So when it's negative 10 times 2 is 20. Negative 20 times 5 is negative 25. So that's just 25. And then negative 10 times 3 is negative 30. Negative 30 plus 4 is negative 26. So 26 plus 1 is 27. So this one is not true. Okay. So because they're not equal to each other. Okay. Now you plug in 2 over 5 here. That's 4 over 5 minus 5. So that is 4 over 5, 25. So that's negative 21 over 25. So, well, 21 over 5. So the right side is 21 over 5. And then you plug in this one here. So that's 6 over 5. So that's 26 over 5 plus 1. So that's 31 over 5. That is not true. Okay. So erase that. So this is not an answer. Now you plug in 0 here. That's negative 5. So 5 is equal to 0. That's 4 plus 1. That's 5. Okay, so this one checks out. Now if you put in negative 8, that's negative 16, negative 21, so that's 21, equal to negative 8 times 3 is negative 24, negative 24 plus 4 is 20, and negative 20, so that's just 20 because absolute value, so 20 plus that 1 is 21, so that's also checks out. So all the answers, so both of the answers are 0 and negative 8. Those are the only answers. And I usually just write 0, comma, negative 8. So that's your answer for number 15. Number 16, f of x is square root a times x squared plus square root a times b times x plus b times square root a, where a is positive and b is positive. Determine the minimum value for f of x in terms of a and b. So the quadratic formula, so this is just a quadratic, not the quadratic formula. This is a quadratic, so the minimum value of f of x is just going to be when you find the middle value. So um, as you heard, if you kind of took a bunch of like classes on math, it's just gonna be a negative b over 2a. That's gonna be your x value at the minimum. So your b is well, the a and b's are not this. It's gonna be y is equal to ax squared plus bx plus c, right? So negative b over 2a, that's your x value. And then you plug it in to find your minimum value. So your b in this case is equal to square root ab, so negative square root ab over 2 times a. So a in this case is square root a. So this is the same thing as saying negative square root a times, oops, what did I write? 2 square root a times square root b over 2 times square root a. So plugging that, so that simplifies to negative b over 2, right, as your answer. Oh, negative square root b over 2. So that's your x. Okay, so x is equal to negative square root b over 2. So we could plug that into our equation. So negative, so it's square root a times the x squared, which is negative square root b over 2. So that is b over 4 plus square root ab times this. So square root a, oops, why do I keep writing that? Square root a, and then the both b squares make a b, and then there's a 2. And then there's a negative, okay? And then plus a b square root a. So this simplifies to b square root a over 4 plus, actually, we gotta keep it as minus because this is a minus. So minus b squared a over 2, which is the same thing as 2 b squared a over 4, right? And then plus, let's multiply the top and bottom by 4. So that's 4 b squared a over 4. So that's negative b squared a plus this is 3b squared a over 4. So that's your answer for number 16. Okay, number 17. Determine all possible real values for x when this is true. Express your answers as a decimal rounded to the four significant figures. So you have to use a graphing calculator for this. So just graph it and see what your answer is. It's basically just that simple. That's all you have to do. Or if you know how to use your calculator, there is like polynomial solvers, I believe, and that's what you just need to do. So the answer is gonna be right. So the only answer is negative 1.2. So four significant figures, so four figures. So 1.235, negative 1.235 is your answer for number 17. Just know how to use your calculator, and that's basically it. 18. N is equal to 2016 factorial uh, plus has sorry, N is equal to 2016 factorial has k trailing zeros, right? So trailing zeros is like let's say like 1000, right? So there are three trailing zeros, or if you have 10320000, there's three trailing zeros. Even though this zero is here, it's in between it. So trailing zeros is everything in the end. Okay. Or if you have but if there's a 1 in the end, that means there are no trailing zeros, right? So trailing zeros if there's a bunch of zeros at the end. So basically they want us to find the amount of trailing zeros in 2016 factorial. So so if you kind of think about it, let's say we have 260, right? There's one trailing zero. So why is that true? Because that's 26 times 10, right? So if you had 2000 let's say 2600, right? That's 26 times 10 to the power 2. So there's two trailing zeros. Power 1, one trailing zero, right? So you need to find the amount of tens. So what is 10 made out of? So 10 is just made out of a 2 and a 5. It's 2 times 5, right? So if you kind of list everything, so how many 2's are in 2016 and how many 5's are there? Because if we have to combine one 2 and one 5 to make a 10. Because we have to multiply them together, which is just basically the idea of factorials. We're just multiplying numbers. So basically, if you kind of think about it, you have way more twos than you actually have fives, right? So let's kind of say 1 factorial, 2 factorial, 3 factorial, 4 factorial, etc., right? If you kind of write them all out, every single even number has at least a 2. But every single 5, right? Every single 5 has 1. So since 2 occurs way more, we don't have to find every single 2. We just need to find how many 5s there are, and that's how many um, trailing zeros we have, which is basically all you have to do when you're trying to find trailing zeros. Find the amount of fives in there. So 2016 factorial, how many fives are in here? Well, if you kind of think about it, let's kind of like list a bunch of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So how many zeros in here? There's 0, 0, 0, 0. There's one zero here, 0, 0, 0, 0, two zeros here. But if you kind of think about it, right? How if we're counting one zero every single time, and then there's another one here, so there's two here, right? So how I'm kind of thinking about this, it's basically if we have 2016 and we divide by 5, that should be the amount of numbers in there that has only one trailing zeros. Have 1 5. Now if you had 2016 divided by 25, that should be it counts for every single other additional one. 2016 divided by 125 equals another plus 1, right? So how it kind of works is it's kind of weird because I need to draw out every single number. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Actually, I'll write 21 down here. 22, 23, 24, 25. I'm not gonna write any more because that's basically the minimum amount that I need to write. So if you divide everything by 5, the only one that's gonna give you like an actual number is one here, right? You have an additional one here, and then you have a 5, well, a 5 here, a 5 at the 5, a 5 at the 10, a 5 at the 15, 5 at the 20, and a 5 at the 25, right? Now you divide it by 25, you get an additional one right here, which is true because there's two in the 25, but there's only one fives in the 5, 10, 15, and 20. Now you keep going, right? 26, 27, 28, all the way to 125. You get 125 divided by 5, you could get 1. So there's one there. 125 divided by 25, that's possible, so you get another one. 125 divided by another 125, but divide by 125 is another one, right? Because 125 is 5 cubed. So there is 3. And that's basically how we're going to count it. So all we had to do in this case is 2016 divided by 5. How many like numbers are there? So using your calculator, 2016 divided by 5. You only need to get the integer part because a decimal means there's just other numbers in there that doesn't get to the 5, but it's just like over the number. So there's 403. Okay, so 2016 divided by 25 because that's just 5 to the power 2, right? So how many numbers have an additional 5? So 2016 divided by 25, that is equal to 80. So 2016 divided by 5 cubed, what is that? That is equal to 16. And let's keep going. 2016 divided by 5 to the power 4. So they have an additional fourth. Okay, oops, I can't type. And that's 3. Now 2016 to the power of 5 to 5. So once you reach 0, then you can stop, right? So, oops, I plugged in the wrong number. And that is equal to 0, right? 0 integer. So now you just have to add them all up. So 403 plus 80 plus 16 plus 3, which should get you an answer of 502. And that's how many 5s are in there. So that's how many trailing zeros are there. Okay, number 19. Consider the conics represented by 3y squared minus 4x squared minus 432 is equal to 0. Determine the exact eccentricity of this conix. So to find the eccentricity of a hyperbola, how do I know it's a hyperbola? Because there's a minus here. So if there's a y squared term and an x squared term, it's going to be a conix. And for that to happen, it's for you to know it's a hyperbola, you need to know that at least one of them has been negative. So either the y squared term or the x squared term has been negative. So it's going to be one of them. So if it's both positive, then you either got you're probably going to have a parabola or a ellipse. But this is a hyperbola. So to put this in the exact form, you just have to put 3y squared minus 4x squared is equal to 432. And then you divide both sides by 432. So 3 divided by 432 is 144. And then minus x squared. And 4 divided by 432 is 108. You go to 1. So this is the exact form. You have a y squared term and an x squared term. And then this has to say 0. I mean 1. So for the exact eccentricity for just a parabola, I mean for just a hyperbola, so this only works for hyperbola, is that you have to take the square root of both of these numbers, so 144 plus 108, over the square root of the one that's positive. So the positive one is the y squared one, because x squared one you're minusing, so that's negative. So the positive is the 144. So square root of that is 12. Okay, so what's 144 plus 108? 144 plus 108. That's equal to square root 252 over 12. So what does 252 factor out to? So 252 is the same thing as saying 2 times 2. 2 to 2 times 3 or 2 times 7. So that is the same thing as saying if you're taking the square root of this, that means you take the square root of this. So you could have 6. 2 times 3 is 6. 6 squared root 7. It's the same thing as square root 252 over 12. So that means your eccentricity is square root 7 over 2. Simplified, right? So there's your answer for 19. You just need to know what like eccentricity is. Okay, question 20. A group of two mathematicians consisting of exactly n men and exactly n women are having a dinner meeting. One of the mathematicians, Cindy, knows that there are k distinct arrangements possible if the group were to sit in a round table with no distinguishable marks, and the men and women must alternate. Another of the mathematicians, Tom, suggests that the group find the minimum value for n such that there will be more than 100,000 k distinct arrangements possible if the group were to sit in a table and they did not have to alternate. So determine the minimum value of n. So to do this, we need to find what k is. So k, the number of arrangements around a circle where they must alternate. So the general formula is going to be the total amount of people minus 1 factorial. That is the general formula to find the amount of arrangements in a circle. So this is just general formula. But now, if we must make it alternate, then there's gonna be two of them, right? So because it's not the total amount anymore, there must be a total amount of women and a total amount of men because they must alternate. So how this kind of works is like, let's say we have four people in four women and four men, right? So let's say there was it's so there's four women, let's call them A, B, C, D, right? And there's four men, which we could call X, Y, V, and W or something, right? It doesn't really matter. So the point is, if we want to put them in order, it has to be like X, Y, B, and then I mean A, X, B, Y, and then C, um, V, and then D, W, right? You have to alternate between men and women. So it's got going around a circle. So how it kind of works is that if we have a person that starts off here and then you go around in a circle, right? Then it kind of doesn't matter that this first person began. And that's why we have n minus 1 factorial. So how many ways can we like rotate around this circle, right? So if we choose women at first or men in the first, it kind of doesn't really matter. Let's just say it's a woman, right? So it's an n. Because they're both n, so it really doesn't matter. So if we have n here, then how many ways can we multiply this around? So that's 4 times 3 times 2 times 1, because we're counting amount of women. So it'll be 4 times 3 times 2 times 1. That's the amount of combinations. Now we need to take for account for men, which is also 4 because they're the same, because they're both n, right, in the question. So this would be 4, and this is 3, this is 2, and this is 1, right? So this is 4 times 3 times 2 times 1. But as I said in the beginning, we don't need this first person, or if we chose this one, it kind of doesn't really matter where it starts. It just has to start at one of the fours, right? Because if you're going around in a circle, then you're gonna go in the same person twice. So that order cannot. So the first person does not matter. So we have to take away one of the fours, right? And this would be the general formula. So how does that work? So if you kind of think about it, what we just did, we have n minus 1 factorial times a n factorial, right? Because 4 factorial, and then n minus 1, so 3 minus 1 is 3. So 3 factorial. And that's going to be our general formula for k, which is the simpler way for me to explain it. I'm not going to go to like the entire mathematics of how this kind of works, but this is going to be the general formula. And this is going to be equal to k. So So if this is equal to k, right, if the possible amount of alternate, what's the possible amount of combinations that they do not have to alternate? Well, it's just n minus 1 factorial, the general formula. N is our total. So there's two n's, n from men and n from women, so there's total two n's. So we can substitute 2n into the n, so 2n minus 1, so total minus 1 factorial. So that is equal to just the number of possible, right? So it's 2n minus 1 factorial. So that amount of combinations has to be more than 100,000 times k. So it's greater than 100,000 times k. And we already know what k is. K is this. So it's 2n minus 1 factorial is greater than 100,000 times n minus 1 factorial and times n factorial, right? So Um, if you kind of want to solve to do this algebraically, it's gonna be a little while. So I'm just gonna use a calculator and I'm just gonna spam numbers. So we have, let's try 5. So 2 times 5 minus 1 factorial. And then let's minus 100,000 because 100,000 times k. Because if it becomes negative, right? If this part is negative, because you subtract this one to this side, then this number has to be greater than 0. So we're gonna have to find the first instance it becomes positive. So minus 100,000 times 5 minus 1 factorial times 5 factorial. Okay, so that's negative. Okay, let's boost, and that's a really big negative. Let's kind of change the 5 to a 10 this time. Okay, 10. So, okay. Did I put too many zeros? Um, 10 minus, okay. Okay, so a little less 0, then put maybe an 11. Okay, so that is the first instance. After the 10, we got an 11. So n is the first. So 11 is the first instance it becomes positive. So 11 is gonna be your answer. So you should just start testing numbers. So it's like 1, 10, 1, 2, 3, 4, 5. Or you can start at 5. I usually start at 5. And then if that doesn't work, go to 10. And then start testing one each number. So I just got lucky and got it was 11. So number 20, the answer is 11. So you just need to know this general formula, and then you can just plug in your calculator and just spam it to find out what the answer is. Okay, and that basically covers everything for the 2016 Division A Regional Algebra 2. Okay, so generally the hardest question has to be 20, if it's kind of weird. But other than that, there's some weird concepts that you need to tackle, like trailing zeros and eccentricity. But other than that, and connexes, repeating radicals. But other than that, a bunch of these are just basic like polynomials, absolute values, probability, and logs. But that's generally it. So take away from this, just learn your connexes and try to learn combinations. I believe combinations of probability, like 20 and was another one and number 9. So that's basically it. Thanks for watching, and see you at the next math record.